Good morning and welcome for another mathematics lesson. Remember to subscribe to this channel and to also share the link with your friends. Find the value of x given that T is a singular matrix. Therefore, matrix T equals to x plus 1, then 4x, 2, and 2x. Those are the elements in the matrix T, and we are told it is singular. So what we should note is that a singular matrix is a matrix which doesn't have inverse. And if a matrix does not have an inverse, then it means its determinant is 0. Therefore, we should know that for singular matrices, whatever we call determinant is always equal to 0. So if determinant equals to 0, then we can express our determinant such that product of the elements in the leading diagonal is multiplied with product of the elements in this other diagonal of the matrix, and we equate them to 0. So when we say 2x into x plus 1, then minus 2 into 4x, this should be equal to 0 because the product of the elements in the leading diagonal minus product of the elements in the other diagonal should give us 0 when determinant, when a matrix is singular. Therefore, this is 2x squared plus 2x minus 8x. This equals to 0. So now we can group like terms together. We shall have 2x squared, and this is going to be 2x squared. This is going to be 6 negative equals to 0. So we can get the possible values of t, whereby we can have a simplification here of 2 throughout, so that we remain with x squared minus 3x. This is equals to 0. Then we can factor out x. Then we have x minus 3 equals to 0. X minus 3 equals to 0. So the value of x can either be equal to 0 when we take now the different roots and equate it to x equals to 0, or x minus 3 equals to 0, whereby x will be equal to 3 because x minus 3 equals to 0. So these are the two possible values of x, which means now the matrix above, matrix T, can be expressed in two different ways, when x is 0 and when x equals to 3. Thank you for following. Subscribe and share.